of more interesting technologies that we use in oil and gas is a wireline technology that has, ever since its introduction in early 1920s, it has really revolutionized the way we look for oil and gas, right? So the foundations of wireline technology, a wireline introduction to wireline cannot be complete without talking about a wireline truck. So wireline truck, which you see right over here, is something which some of the people might be familiar with. It's a very common sight in areas where we explore oil and gas. It's a very specialized truck with a cab at the back, and it does some interesting things. What interesting things it does? It's part of our presentation today. So, overview of wireline in the oil and gas industry. What wireline is? Wireline is essentially a technique in which you lure specialized tools. And these specialized tools, we are going to talk about these specialized tools a little bit as well in our presentation. But it lures these specialized tools into wellbore using electric cable. That's why it is called wireline. And why do we do that? We do that to gather subsurface data without actually removing the tubing. So it gives you a lot of flexibility in evaluating your reservoir without actually removing the tubing and without doing anything invasive to your wellbore. So some of the common phases that we use is wireline is used in drilling, completion, production, and abandonment phases. So you can see it is effective in entire life cycle of the well. It has its efficiency and cost benefits because of its small footprint, quick mobilization. It reduces the operational expenditures, and it provides you the real data in real time. And based on that data that is coming in real time, the operators can actually make some very key decisions. So I have an animation over here, which I hope I can play. And before we get right into the mass of this video, right? Well, essentially, the reason for me to embed this video in this presentation was to give you a quick idea from the very start of the presentation. What are we talking about, right? Sometimes it becomes very difficult for people who have not worked in energy sector to kind of relate to these technologies, right? So just to give you a quick flavor of what we are talking about. So what you saw over there, where you joined three tubulars together, was what we call a tool string. It may look like a tube, but it is packed with electronics, right? It has different type of sensors. It has different type of the tool string, the three different tubulars. Each tubular was supposed to do something different. So that tool string that you saw, that is now being lowered into the wellbore. Now you see something interesting happening over here, right? You see all these measurements that these tools are making, right? What is happening is that there are different type of tools. There are acoustic tools, there are electric resistivity tools, there are nuclear tools, and there are magnetic resonance imaging tools. And what they are doing is that without actually touching the reservoir, they are trying to capture different properties of that reservoir. I'm going to pause over here. I'm going to talk about what is happening, right? So all these tools which are taking different measurements, they are developing what we call a wireline log. So what you see on the screen right over here is what we call a wireline log. And they are measuring different parameters, and they are saying that across this depth, these are the different parameters, and they are plotting them, trending them on a graph, and they are doing it all across the entire section of the wellbore. All right, so now it should give you an idea of what we are talking about. What is wireline, right? Now, this tool string that you see right over here, this is essentially a big array of sensors, and it is lowered into the wellbore by using an electric cable. And from that electric cable, this technology gets its name wireline. All right. Okay. So a couple of reference terms that we are going to talk about is we saw this wireline truck. I showed you a picture earlier in the presentation. This is your drilling rig, and this is your logging tool. The logging tool was the one that was making all those measurements. And you can see through a series of pulleys and winches, it is lowered into the wellbore right over here. All right. Why we are doing this, right? There is one key aim of wireline to determine how much oil is in that place. Right? Client wants to know how much oil, what depth, and what is the recoverable amount of that. So we actually use a formula for that, which is oil in a certain particular amount of volume is area, height, porosity, versus and saturation. And there are different type of factors that we are using in that as well, right? Saturation is the amount of fluid over the pore space in percentage. You are using water saturation factors. You are using oil formulation volume factor, and you are also using SH, which is hydrocarbon saturation. So typical wireline services, to make it simple, wireline services can be divided into two categories. One of them is called open hole services, and second one is called cased hole services. Open hole services are the ones in which the tool is directly interacting with the reservoir. You can see this is the reservoir. You can see the reservoir boundary, and you can see the tool over here, which is directly to evaluate the formation characteristics. Cased hole services actually happen when the casing is already in place, the well is producing or about to produce, right? Why we do cased hole services? To make sure that the well integrity is good. So they do well integrity logging. So they do cement bore logging. They do perforation. So perforations are making the holes over there so that oil can flow, and also production logging. So production logging is essentially to figure out how much your each zone is producing, how much water, how much oil, and that is very important for the production engineers. Examples of open hole services are essentially related to petrophysics, geology, and reservoir. You are doing all those what we call wireline logs, and you are essentially trying to figure out you are making a picture of what is happening downhole, right? What downhole actually looks like by using different type of, you are using electrical resistivity, you are using magnetic resonance, you are using nuclear tools, you are using acoustic tools, and you are trying to make that picture. Different type of, these are tools in real life, what these tools actually look like. They might look like a tube, but you can see they have a lot of sensors packed in a very tight space. The examples of cased hole services are well integrity, perforation, and production. And essentially so what you see over here is a cross section of a wellbore, and you are seeing, what you are seeing is that a wireline gun making a perforation. So you can see it punches a hole by using an explosive. And then this is an example of a production log. And over here, what you can see is a production logging tool. And it is quite fascinating, right? The way they operate, the way the whole multi-physics work. It may be beyond the scope of this presentation, but the amount of physics that is involved. Because what you want to do is you want to go down the hole, you want to make accurate measurements, and you want to provide those measurements to the client because the client is actually waiting for those measurements to make very key production decisions. Okay, so wireline uses continuous cable to convey tools into the wellbore for measurement, intervention, and manipulation tasks. We already talked about open hole and cased hole activities. Both differ very much uh, from each other. Open hole is when you are drilling the well. Cased hole, when you have drilled the well, you have completed the well, and now the well is about to produce or it is producing already. Pressure control equipment is very critical in these tasks because pressure control equipment actually makes sure that all that wellbore fluid does not leak into the environment. So a little bit on the history of the wireline, right? When this technology started coming in, it was only in early 1920s when two French brothers by the name of Marcel and Conrad Schlumberger, they developed what we call electrical resistivity tool. And that's where the electrical wireline logging technology started moving up. Because before that, the clients had no, or people had no way of figuring out what is downhole, right? They would drill a well, they would keep on punching holes in the earth with a prospect that maybe one of them will start producing, right? But with the electrical well logging, it was a revolutionary technology in 1920s, right? Now you could actually figure out what is down. And with the passage of time, we have advancement in cable technology and tools where you have very high uh, 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 technology tools packed into a very tight space, making all these advanced measurements. One of the interesting facts which I want to mention over here is this technology is not just used on our Earth. NASA actually used this technology when they are sending all those rovers on Mars and Moon to figure out what are the subsurface characteristics of all those planets. So the technology that was actually developed for oil and gas was actually later used in and still being used in space exploration. So it's a very interesting concept when you think about it, right? Um, uh, the the these tools are so complicated and so um, uh, their fidelity is so high that even you use it in very demanding environments, right? Um, so one of the other types of wireline that we sometimes kind of characterize under wireline is slickline mechanical operations. So slickline is actually not an electric line; it's just a mechanical line, a cable, and then you use different type of manipulation techniques to do some mechanical intervention without telemetry. So it is all by running to a certain depth and doing certain mechanical operations but still using the similar setup as what you will use for the wireline operations. So a role of wireline across the whole well life cycle, right? As I mentioned earlier, this technology is applicable throughout the life cycle of the well. We use it for exploration, appraisal of the well, so very much in the very early stage of the life cycle of the well. It is used to determine how much oil is there. Then in the drilling and completion operations, wireline tools evaluate cement integrity, so cement pond log. They inspect casing, they assist in perforations for safe and efficient well construction. And during the production phase, they are used to identify fluid zones, trying to figure out where the water is coming from, where the gas is coming from, where most of the oil, in which zone most of the oil is, and making the valve measurements without halting the operations or killing the well. And then at the very last, integrity measurements and abandonment. Once you are done with producing the well has gone into a phase where it is not economical to produce. Wireline actually makes sure that it detects any casing damages. It sets plugs which are actually permanent barriers for compliance and safe well abandonment and environmental protection. Economics and operational importance of wireline. It reduces the cost and downtime by enabling faster intervention. And usually a wireline crew on the well is uh, less than 10 people. So it is not a very huge operation, right? So if it's not a huge operation, it is usually very cost effective. And it helps in proactive asset management. It provides very timely, accurate downhole data to detect early issues and prevent costly failures. And uh, selective target intervention, it helps to identify zones and intervene in those zones while optimizing operations in multi-zone and complex reservoir, right? So when we talk about well bore, right, we are not talking about a straight bore and with just one zone producing. In these complex environments and the current operations that we see with the wireline, right, there can be multiple zones that are producing. So wireline helps you to identify those zones and also to intervene in those zones. For example, if you want to do perforation in those zones, or if you want to set plug in those zones, wireline helps you do it. So types of wireline systems. I talked about slickline system, which is actually a mechanical system. It's not sending any electrical signal. It's not getting any telemetry from downhole. It is a purely mechanical system which uses a standard non-electrical steel wire for reliable and cost-effective mechanical intervention. Most common applications for slickline is to retrieve downhole devices. So if you are fishing, something has fell in the downhole and you want to fish it, you will use a slickline, shifting sleeves and basic depth correlations. These are very simple basic tasks. In terms of mobility and efficiency, these are very highly mobile units, usually a truck mounted unit, which you can see over here with a boom crane, and it is lowering the tool downward, and it's a very quick, efficient operation. E-line systems are effectively electric line systems. Now, with the electric line and mechanical line, the difference is the data and the signals that you are getting. In mechanical line, you are not getting any signal. It's just all by feel and by performing certain operations. With electrical line, you are getting information from downhole. So the E-line system will actually include an insulated electrical conductor and armor wires, providing mechanical strength for downhole tools. It gives you real-time data transmission with a lot of measurement capability as well, right? So with the E-line, you can support measurements like resistivity, density, neutron porosity, acoustic properties, pressure, and temperature. So if you have a pressure and temperature gauge that you are lowering downhole, it will be able to give you real-time measurements. So E-line is very critical for formation evaluation, well integrity diagnostics, and production optimization. So one of the examples which I is braided and heavy duty line applications. What you see right over here are different type of tools that are used in these applications for measuring different type of things downhole. You will lower this tool string using a wireline on a slickline drum through a sheave. It goes to the top of the lubricator, and then there is a BOP, which is a blow-on preventer. In case you want to isolate the pressure, you can actually close or open your BOP. And then over here, there is a Christmas tree, which is a series of valves in parallel in series to control the flow. So comparison of the wireline cable, there are different type of cables. There is slick line, which is simple mechanical cable. There is electrical line, which is electrical line with a lot of armor to provide its mechanical rigidity. And then braided line strength, which is more durable, a lot of strength, and it is ideal for high pressure operations. So depending on your well depth, your pressure, temperature, and objectives, right? If you want to do a mechanical intervention, you want to do electrical intervention, um, you will use different type of cables for your operations. Wireline equipment and components. So there are two types of wireline units. One is called a surface unit, which is you can see right over here. It has what you can see a wireline truck. There is a telemetry system right over here to communicate data back to office, where production engineers can make decisions. And then there is an offshore wireline unit as well, which you can see right over here. It is a containerized unit. and it can be usually placed on an offshore platform. So the wind system is very important. Wind system, you can see a part of a wind system over here. Wind system is usually at the back of wireline truck. For the surface operations or the land operations, wind system functionality, it controls the cable movement, which presides over speed and tension and critical for the safe wireline operation, right? All of these controls are usually very computerized. So modern wind systems feature computerized control to monitor tension, depth, and a cable condition in real time. Um, One of the things about the land wireline units is that they are designed to ensure surface mobility. So they will be with a truck or a trailer and a skid mounted configuration for various environments. Skid mounted configuration is more for the offshore platforms. And surface unit integrate mechanical, electrical, digital systems and maintenance in a very complex, uh, a very compact package. So you can see these are packed with electronics, which are getting all the telemetry. They are providing also power to the downward tools. So they are usually very high reliability systems. This is just a cross section of of an electrical conductor that is used for the wireline cables. So that you can see the electrical conductors, but you can see also the armor which is across the cable as well. So the armor is there to make sure that it provides the because you are lowering all that. So the tool that you are lowering in the wellbore, it has a weight, and then you are lowering it 2 or 3 kilometers downhole. It has to go through all that wellbore, right? So you want to make sure your cable is gonna uh, take that tension. Electric line cables are usually embedded with insulated conductors and armor to enable power and data transmission. Material selection is based on its a balance between strength, flexibility, and resistance to harsh environments, pressures, and chemicals, right? So yeah, there can be presence of CO2, H2S in the wellbore. There can be high temperatures and high pressures. High temperatures, we are talking about 270 degrees Celsius, and pressures, we are talking about 10,000 psi or more. So you can see these are very harsh environments. So the equipment that is designed for this harsh environment is usually to a very high reliability standards. One of the common failure modes which we see in the wireline cable is cable fatigue and maintenance. Because imagine you are lowering it, and once you lower it, you have to sometimes go back and make measurements again to make sure that your measurements are correct. All that repeated running in hole and pulling out of the hole will result in a lot of bending stresses to the cable. So regular inspection is required to ensure safe and reliable operations. So measuring head, one of the things about it is that we have advanced in wireline technology so much is that now we can actually do depth correlation. So the amount of um, uh, there are sensors in the wireline unit which will measure the depth of the well and how deep the tool string has gone already, right? And for that you have to make sure those sensors are calibrated correctly. So the tool string composition, right? And now I talked about that these tools could be either based on a single physics, that means that they are doing electrical resistivity, or they can be based on multi-physics. That means they are doing electrical resistivity. They can be also doing acoustics. They are also shooting neutrons by using a nuclear source into the uh, into the formation. So the tool string composition depends upon what kind of a data you require, right? Uh, Tool string usually consists of sensors, jars, and safety devices tailored specifically for specific wireline tasks. So when we talk about safety devices, there is an emergency release. So let's say if you get stuck somewhere in the downhole, you can use that emergency release to disconnect from the tool string and pull yourself out of the hole. Usually, when we are designing a tool string, the composition of tool string also takes into account compatibility with the wellbore fluid, pressure, temperature, and strength when designing the tool string for reliability. And usually, if you remember the video which I showed you earlier, there were 3 tool strings that they connected together, right? They just um, threaded them together, and that is actually the last point on this slide, which is modular flexibility, right? The tool string allows the customization for different wells, enhancing precision and operational efficiency. Surface data acquisition, I briefly touched upon it, but surface data acquisition is very important, right? All that data that you are getting, right, from the wellbore, it is processed in real time sometimes, and it gives you a very real time information to make informed decision making. And while doing so, you have to make sure that you control all that data, you store it, and also power management, right? You have to power that tool downhole, and it is 4 or 5 kilometers in subsurface, right, in a wellbore. You have to provide that power all the way from surface to downhole. So all that power management is very important, and that is also packaged as part of the wireline system. We talked about the open hole and cased hole logging applications. This is very important concept to grasp, right? Open hole logging purpose is to evaluate formation properties like lithography, porosity, fluid saturation, permeability before casing is installed. And why this is important, right? Once the casing is involved, you won't be able to determine these properties because you have a casing which is a piece of pipe, right, between your tool and your wellbore. So you won't be able to evaluate all these important properties that are required to make production decisions. So you have to do it in an open hole logging scenario. Then once the casing is deployed, then you need case hole logging tools, right? The case hole logging tools will assess well integrity, cement qualities by using cement bond log and production behavior after the casing is installed. Together, both open hole and cased hole provide a full evaluation framework supporting different life cycle decisions of the well. Perforations using wireline. So one of the things that we use wireline is to make perforations. And perforations are these holes through which the oil and gas will come through the formation, enter the casing, and into the tubing, right? So perforating, and you can see this is a cross section of like a perforating gun. Perforating provides flow paths by firing shape charges through the casing and cement to connect the reservoir and the wellbore. Wireline systems provide precise depth control and accurate placement of these wireline perforating guns to align with the target zone. So you know your zone is at a particular depth, you will lower your wireline gun and you will fire these shape charges so that you can connect your reservoir with the wellbore fluid. Perforating design considerations include type of a charge, so type of explosive that you are using, short density, phasing. Phasing is the distance, and allowing selective zone perforation and stage completion. So this is critical, right? The depth in perforation and your short density and your charge type is very important. And your phasing, which is the distance between the perforations, is also very important. What you don't want is to perforate a wrong zone. What I mean by wrong zone is that, in oil and gas production, right? You produce oil, gas, and water. You want to produce as less water as possible. And usually you want to produce as less gas as possible as well, unless or until you're specifically looking for gas. You want to maximize your oil. So usually you do perforations in zones which are rich in oil, less in water, less in gas. So production logging also have a lot of value that it brings to the table. It helps in diagnostics. It also tells you where the water and gas breakthrough is. Cross flow. Cross flow is when the flow will go from a high pressure reservoir to a low pressure reservoir, and mechanical failures in the reservoir system. Production logs are performed under dynamic conditions. That means without killing the well, you are doing these production logs using very specialized tools which require careful planning. And what you gain from it is that you will get targeted intervention, optimize your completions, and enhance your reservoir management. Well integrity and diagnostic services, it's also part of the wireline scope of work. What you are actually doing is you are doing early issue detection, timely issue detection of corrosion and barrier failures will allow you to do a proactive maintenance and reduce environmental risk. So if you see that there is a corrosion failure, and if you see that your casing integrity is being compromised, you can do early intervention to mitigate the risks that are associated with those failures. It also aids in compliance with the regulatory framework, emphasizing. So, in some of the areas, you actually have regulatory requirements to run your well integrity test to make sure that your well, over the period of time it is producing, it meets certain requirements which are set forward in regulatory compliance of that area. So, uh, safety considerations in wireline operation safety, as you know, like in most of the oil and gas operations, all the way from downstream to upstream, safety is considered very, uh, uh, it's a paramount responsibility, right? Safety towards the employee, safety towards the environment as well. So, comprehensive safety management is part of the wireline crews. Pressure control equipment, as you see, they are using lubricators, blowout preventers to make sure that uh, um, there is no uncontrolled exposure of oil and gas to the environment. So, equipment like lubricators, grease ejectors, and blowout preventers are maintained in a regular fashion to maintain well control and allow safe cable movement. And then, obviously, last but not the least, is personnel training and communication. Usually, the wireline operators are very trained personnel who are not only trained on the technical side, but also to identify hazards and usually the emergency response that can result in a particular situation. Operational limitations of wireline. So wireline do have some operational limitations. For example, in highly deviated and horizontal wells, uh, with limited gravity-assisted tool movement, it reduces wireline effectiveness. In that case, if you have horizontal sections or highly deviated wells, in those areas, you actually use something which is called a wireline tractor. So wireline tractor is essentially a, a, a it's a think of it like a car but downhole. So it is pushing all those tools in horizontal sections without any gravity assistance, right? Because in the typical wireline operations, you are very much relying on gravity to lower your tool string. But let's say if you are in the horizontal section, right, you don't have much gravity assistance. Then in that case, there is a limitation to the wireline. However, there are ways to overcome those limitations. Extreme temperatures and pressures also, uh, as we are going deeper into the wells, because a lot of maturing fields were shallow fields. Now we are going deeper in those fields. We are encountering extreme pressures and temperatures, right? Which can result in equipment limitations and reliability issues. So that also plays a very important factor when you are doing a tool string design. Mechanical force limitations also, obviously, right? Wireline provides less mechanical force compared to coil tubing, and it cannot do very heavy intervention tasks. It can do light intervention tasks, but there's not a lot of mechanical force right over there. So it's limited with heavy intervention tasks. And combining wireline with complementary technologies helps to overcome limitations and optimize intervention strategies. So in those kind of scenarios where you have equipment limitations or you have movement restrictions, in that case, you have to combine wireline, typical wireline technology with advanced technologies to help assist in getting the measurements that you want. So, wireline versus coil tubing. A lot of people who have worked in oil field, there are advantages and there are disadvantages. The advantages of wireline is it's very fast, cost-effective data acquisition with light mechanical intervention. Strength of the coil tubing is that coil tubing is essentially a coiled tube around a spool, but coil tubing actually gives you an ability to do heavy mechanical intervention jobs, fluid pumping, and stimulation. So it can actually do stimulation, which is something which wireline cannot do. It can help with heavy stimulation, heavy interventions where you require a lot of force. Then you can use hydraulic tools at the end of the coil tubing to make those heavy interventions. And when you choose between the two methods, depending on your well objectives, your conditions, and economics, right? Usually, coil tubing requires a bigger footprint. That means it is more expensive, while it has a smaller footprint. Um, with the advancement in wireline technology and artificial intelligence, there is a lot that is happening in this field as well. We are obviously getting better data with improvement in sensors. We are getting better data through advanced telemetry and high resolution sensors. With the integration with the oil field platforms, now you can get the data in real time. You can make decisions, and some of those decisions are actually made by artificial intelligence. And also automation and remote operations. Now we are reducing the crew on the well site because we want to minimize safety concerns to the people. We are going more towards the remote operations. So you have very less number of people on well site. They will hook up all the sensors. And then after that, it's all remotely being done from a location which is far away from well site. How do you how where do I see wireline technology going forward? I do see a very bright future for the wireline technology. We are adapting to harsher conditions, high temperature, high pressure environments. We are going deeper and we are going in more challenging reservoirs, right? With integration with the digital workflows and artificial intelligence, now we can get decisions which are more mature because we have a lot of data from all these years. Our AI with being trained on those data sets, now it is making decisions which humans used to make with a very high accuracy. And now we see wireline operations not only being used in traditional oil and gas application, we do see them being used in geothermal applications, lithium mining. We are seeing them in carbon capture and sequestration methodologies as well. So it is becoming a very universal technology, and it not only supports traditional but also the new energy, and it also helps us to make sure that we abandon the oil and gas wells in a more responsible manner. All right, that was my last slide. I think we can open the questions now.
Excellent. Looking to see in chat, any questions, anybody? See, just one clarification that I would like is the sensor goes along the pipe, goes along the channel there?
I would probably go back to one of the slides that I have. All right. So you see an array of sensor over here, right? So
yes.
This is probably 20, 25 feet long, right? And on one end, it is connected with the electric line, which is transmitting all that data to the surface and also powering the sensors, right? So what you do is that this 20-foot sensor, let's say for the sake of argument, this 20-foot sensor, you will lower it in the wellbore and it will go all the way from the very top of the surface to the very end of the well. And what you do is that as you are going through all that sections of the well, you are making all those measurements. So you are actually...
So it's moving along the pipe.
Yes, it is moving along the pipe. And think of it, it is creating a digital twin of that well.
And it won't, what if it encounters something that's touching the pipe? Does it stop?
Yes. So in that case, it does stop if you have high deviation. For example, if you have like horizontal section, right? Now it's not gravity assisted, so it will get stuck over there. So what you do is in that case, you either jar the tool, so you will use mechanical intervention to push it, or you will use a wireline tractor, which is, think of it like a remote control car. You will use that wireline tractor. It is also part of the tubing, the sensor array. So it uses wheels to move that tool string further into the wellbore.
Wow. Okay, we have a question from CC Jules. Go ahead, Cece.
Well, thank you very much. A very good presentation from Mr. Hassan. When I saw the, the topic of this wireline technology for data transmission in the before. But when I see now the development, I remind now that it is regarding the oil gas field. So I was confused. Maybe the topic should be exactly or precise that oil gas wireline technology, because the wireline is used in many fields like data transmission, telecommunication, uh, digital data computing, and so on.
So, Cece, thank you very much for the feedback. I will take that into account. One of the things wireline is a term that was coined in 1920. Before that, there was no term like wireline, and it was coined specifically for wireline operations. So, what I would suggest is if you go back and research a little bit on wireline, and when I say wireline, right, there is no space between wire and line. So that could be one of the distinctions. So wireline is a term which is very specific to oil and gas technology. But going forward, I think I can take that into account to make sure that people are aware where is the application of this technology.
Okay, thank you very much.
Okay, we have a question here. Do you see the question in chat from Pedro?
Yes. So great question. Explaining. Can you explain more on production logging and reservoir diagnostics? Certainly. So production logging and reservoir diagnostics, I think we are on the right slide. Reservoir diagnostics, it's a very broad term, but I would take one example of reservoir diagnostics, which is, let's say, when you first did completion of your well, you knew that which zone is producing. So you did your perforations in that zone, and you knew that that zone is going to be producing certain percentage of oil, gas, and water. And after certain amount of time, you know that, right? The reservoir depletes. So it is usually in the form of a curve. So a reservoir will deplete, and then you want to figure out now how much oil is that zone producing. So you are essentially doing a diagnostics, right? You are trying to figure out, okay, my well was producing, let's say, 60% oil. Now it's producing 30% oil. Which zone is contributing most oil in my well? Because you can have multiple zones, right? So when you are doing that, essentially it's a diagnostic job, right? You will lower your production logging tools, and you will try to figure out which zone is producing more oil. Then similarly with the well integrity, right? One of the key tasks that wireline performs is what we call a cement bond log. Cement bond log is done to check the integrity of cement, which is behind the casing. It acts as a well barrier. Sometimes if that cement is not good, it can compromise your casing integrity. Your casing will corrode, and it can result in a bigger well integrity issue. So by running that cement bond log over the period of time, especially towards the abandonment of the well, you're making sure that your well integrity is preserved and there is nothing wrong with your casing. Production logging is essentially, it's a different type of production logging is usually done when your well is producing. You have already completed your well, it is already drilled, it is completed, you're producing. And production logging, I will go back to the initial example. You're trying to figure out how much your well is producing, what are the flow rates, uh, which zones are producing how much oil, how much gas, how much water. Thank you.
Okay, then we go to Patricia, has a question in chat. Can you explain more on production logging and reservoir diagnostics?
Sorry, I just answered. I thought it was from Pedro, but I just
Oh, okay. Yeah, there was
yeah.
the one before that from Pedro.
So
This is
Pedro,
long.
I'm sorry. Sorry, I missed that one.
Okay, that's the one.
Considering the realities of a small island developing states like Cabo Verde, where operational logistics cost efficiency, environmental safeguards are crucial, how do you foresee the evolution of wireline operations in coming years? In particular, how can advancements in digital systems, smart sensors support safer real-time data acquisition while reducing operational costs in increasingly complex offshore well environment? One word for this: remote operations. So, as you guys know that with the advancement in technologies, miniaturization of electronics, the footprint of wireline is decreasing. Other footprint that we are decreasing is number of people on site. So with the remote operations, we are supporting that vision that we will reduce the number of people on well site to reduce exposure to any safety risk. Now, in small developing island states, operational logistics, cost efficiency, environmental safeguards, uh, there is a lot of scrutiny and a lot of awareness around pressure control uh, around the wireline operations. So pressure control equipment, lubricators, blowout preventers usually go through certain certification to make sure that they are up to speed, they are up to the standards and codes. Usually, a lot of these safety equipments are manufactured and maintained according to certain API standards. For certain equipment, there can be different standards. So that actually also is playing. The one thing which I would probably go back to is the regulatory framework. In some of the offshore environments like offshore US, offshore Canada, offshore Norway, in North Sea, UK, the regulatory framework is very strong, right? But in some of the other environments and some of the other offshore exploration areas, especially in Africa, the regulatory framework is not that strong. Then it comes back to the internal procedures and standards that a particular wireline company follows. Some of the bigger names that we have in wireline, usually there's a lot of operational integrity, awareness, and standards that they follow, even if the regulatory framework is absent. So I think picking up the right operator with the right technology is very important.
CC Jules, do you have another question? Let's go ahead and CC, do you have another question?
Yeah, I have another question. You talk about the coiled tubing. In which case we use the coiled tubing, and what is the difference between the straight hard line tubing and the coiled tubing? What are the quality in terms of quality and resistivity and so on, and in which case we use each of them? Thank you.
So coil tubing is usually very small. So the diameter of the coil tubing is very small, and it is made of materials which are very flexible. So it is the flexibility uh, or malleability of that tubing is to a point you can actually roll it on a spool. So where it is used is primarily in heavy intervention operations, right? Where you are using hydraulic tools, let's say, rather than to to use explosive, you are punching holes or you are doing acid stimulation. So, and also in Middle East, coil tubing is also used very extensively for coil tubing drilling, CTD. So rather than using conventional drilling technologies where you are using drill string and bigger bits, by using CTD or coil tubing drilling, you can actually use coil tubing to drill lateral sections, and you can actually make multilaterals with those coil tubing drilling. Usually, the distinction between wireline and coil tubing, uh, wireline is used for more light intervention operations where you do not require a lot of mechanical force. Coil tubing is used for heavy intervention operations. Coil tubing also provides you additional flexibility to do stimulation, which is pumping fluid at a very high pressure, and also gives you the flexibility of doing drilling by using a bottom hole assembly for coil tubing drilling operations.
Okay, thank you. Thank you so much.
And I see a question from Mosa in chat.
Which kind of material you recommend? Can you explain a little bit of which material for what you are talking about, Musa?
Yeah, because there's different materials for many different parts of this.
Yes. So I can probably just give you a lot of these wireline tools. Wireline cables are usually made up of there is a armor sheath which is combination of Kevlar and some other materials, polymers, especially very tough polymers. For the wireline tools, we use a lot corrosion-resistant alloys. So stainless steels as well as Inconel or nickel-based steels. They're commonly used for the wireline tools because they are going through different operational environments, and then some of we also need to maintain integrity of that tool in a high pressure, high temperature environment as well, right? So you use materials which have high tensile strength, higher yield strength, have more mechanical rigidity.
I was wondering if there's a lubricant used inside it, so as it's moving, is there a lubricant?
Usually not. Your oil in the well acts as a lubricant.
Well, and then you were talking about it also senses for nuclear energy.
Yes.
Do you find that common or just a safety, just for safety's sake?
So what it does is that it uses a nuclear source, which is emitting neutrons in a wireline tool string. There's a specific, I will try not to go into too much detail at that one because it becomes a very complicated physics subject. But it has a neutron source in the tool string that is emitting neutrons into the reservoir. And what it is doing is that by emitting neutrons and getting them back, it is trying to figure out the formation properties in terms of how much porosity is there, it is also trying to determine how much water is there because you're not taking any physical sample, right? So you don't know. So you are using that neutron source to determine the lithography of the formation. Because water, oil, gas will absorb neutron at a different rate. And when they absorb at a different rate, you can, by using different algorithms, you can figure out how much water, gas, or oil are there.
Where does the water come from?
Usually your natural water downhole. If usually water is quite shallow, but even in the deeper reservoirs, there will be some water, usually the subsurface water.
Doesn't the water and the oil separate?
It does. It does, but you still have dissolved water in oil. It's not like 100% separation, right? And when you are extracting oil, the water will also come through. Yeah, initially you might be taking a lot of oil, you might be getting a lot of oil, and that is a very classic issue in oil and gas exploration. Initially, when you drill, you are getting a lot of oil, you are probably getting 90% oil, but then suddenly you will see water ingression. So your 90% will drop to 50%. It is still economically viable to extract that oil, but now you have to do something about that water as well.
Looks like we're coming to the end of our hour. Very fascinating topic. There's a lot to study here. The presentation will be available in a couple of days on the student portal. Just go onto your quick menu and look under AIU Live Classroom. So do you have anything more to add, Hassan Ali, before we close the class?
No, I just want to thank all the participants for their awesome questions and patiently listening to the presentation. Some of these concepts can be very difficult to comprehend, right? So I appreciate your patience and perseverance, and I would definitely recommend go back, take a look at this topic. Since there is some interesting material out there, which can probably give you a lot of insight into this technology. What we did today was just touching on the surface, right? It was just to give you a flavor of, hey, you know what? There is something out there that can do this kind of thing subsurface. But there's more to this. There's a lot of physics involved in this.
Yeah. So it's like you could extract the oil and then analyze it up there on the surface, but it also helps to analyze what's going on in the pipe going in down into the well.
Exactly.
Wow. All right. I think that'll do it. Thank you so much. We'd love to have you back and keep bringing these very fascinating topics to us.
Thank you, Prof.
All right. I'll let everybody unmute your microphone so that you can say thank you and bye and have a wonderful day.
Goodbye, sir.
Guys, thank you. Thank you very much. Bye.
Thank you. Thank you. Thank you so much,
Bye.
Mr. Hassan. Thank you for the great presentation.
Thank you, Sisi.
All right. That'll do it.
Thank you, Prof.
Bye-bye, everybody.